Okay, so hi everyone. Today we're going to solve another problem that is LeetCode 1657, and this problem is determine if two strings are close. It's a medium level problem and it's a good problem. It has a decent like to dislike ratio. So in this problem we are given two strings and we consider them close if you can attain one from the other using the following operation. So you are given some operations and you can perform those operations on a string 1, let's say your string 1, and you need to apply these operations, right, and convert this string to another string that is also given to you, that is string 2. And now this problem says that those operations are you can swap the characters. So for example, you have a b c and you need to convert abc to acb. Then you will say that I can apply operation 1 and swap these characters and it will be acb, and this is equal to acb, right? And this string is now converted and we will return. So we basically have to return true if word 1 can be converted to word 2 by these following operations. And another operation is you are given this string a and b and you need to convert this to b a, right? You will say that a has a frequency of 3 and b has a frequency of 1, and in this case a has a frequency of 3. Okay, this is not true, and this has to be like b b a. So a has a frequency of 1 and b has a frequency of 3. You will say that I can convert the frequency of a, I can. So you will say that every character that is a will be converted to b in string 1. Let's see what this will do. So a is now b, a is now b, a is now b, and b is a, right? And b is also converted to a. So now you have this string which is equal to this one, and now you say that it is converted. So why have I showed you this key to value pair of frequencies? So when I say that a is now converted to b, then you will make a comparison. So in this case a is equal to 3, and in this case in the string word 2 a is equal to 1. So this should be 1, right? This should be 1, but this is 3. So in order to change its value to 1, so a will now go and look all the characters in the map and ask each and every character if they have that required frequency, and that is 1. So it's asking for 1, and it will find that 1 has that frequency and it will swap with it. So now 1 is equal to, so this is 1, and these values are now swapped. When they are swapped, a will again check and it's fine, and then b will again check and it's fine, and it's good to go, right? It makes perfect sense. So yeah, so this is the second operation where we can change every occurrence of a character to the other and the vice versa in word 1, so that we can convert word 1 to word 2. Now let's take an example. So we have ABC, and I think I have showed you the example. And yeah, so now for this problem you can either return true or you can return true. So you will return true if word 1 can be created to word 2, and you will return to false if word 1 cannot be created to word 2 by applying those operations that are given to you any number of times. You may apply them 0 times or you may apply them 1000 times, and you are just not able to find the word 2. You're not able to convert the word 1 to word 2. In that case you will return false. Now there are two approaches. So either you can take the first approach, and that is true, that is the conversion of word 1 to word 2, and see if it's a true or not. In that case you will be trying and every possibility of word 1, exchanging the swapping the character, swapping the frequency, and doing this and that, and then at some point you will find that word 1 is now converted to word 2, right? So as you can see, this is a very inefficient method. It can be exponential, because you will be using recursion, backtracking, and then maybe dynamic programming. Nothing will help you because this is a very lengthy part. Or you can work on this false character, which means that you will set some conditions. Okay, if this condition is violated, then return false. If this condition is violated, then return false. If this condition is violated, then return false. And the last condition is, if the above ones are not violated, then return true, right? The last condition. So we can obviously work on this part. So I will suggest you for this problem or problems like these to work on the false part. like what are the violating conditions that could be there in which a string cannot be converted to string 2, a word 1 cannot be converted to word 2. So those conditions are, so the first one is length. If word 1 length is not equal to word 2 length, in that case, if we have a b c and the string that you want to make is ab, these strings are matching, but the substring is matching, but the whole string is not, and there is no possible way, there is no operation where you can destroy this character c, which means that, and the other case is also true, if you have ab and you need to create abc, then there is no way that you can create the character c, right? You cannot create c and you cannot destroy c. So in this scenario, you can find that if the length is not equal to, if n is not equal to m, n is the word 1 length and m is the word 2 length, in that case we can simply say that it's a false condition. So this is a condition which should be satisfied, and if it is not, if this is the condition, then it will return false. Second condition, if the characters must be consistent in both strings. So what do we mean by that? What do we mean by that? For example, we have a b c and then you have b a z. You can swap this a b c with b a z, sorry, not b a z, you can swap this a b c and it will become b a c, and then you have b a z. Now there is no operation available to you which can convert c to z, right? So there is no operation where you can change a character. Although you can change a character, you may not change a character. In operation 2, what we do is we swap the frequency. So for example, if you have a, which is 1, for example, if you have a b, then you can change their frequency, which means this will be b b a, right? But this is not a generation of any new character or deletion of any new character or conversion of a character to any other. So for example, aab is now converted to baa, sorry, bba, right? But in this part, aab and then we have bba, we still have b and a as the character, a and b as the characters, and similarly a and b are there. But if we have a b c, then we cannot convert c to z, which is why this is a violating condition, and the characters must be consistent. Now third condition is, if you have different frequencies. So for example, we were iterating over the map to find the frequency and swapping it with something, right? But let's say you have a frequency like this, b a a b c, right? And so this is word 1 and the word 2 is b a c, right? In this case, the frequency of this character is a is 2, b is 2, c is 1, and in this case the frequency of a is 3, b is 1 and c is 1. Now you can see c frequency are same, so it's fine. B frequency and b frequency is not same. So now one will look for the frequency of any character that has the frequency 2, and in this case there is no character that has the frequency 2, so it's a not a very good thing. So we will return false in this case, that b cannot satisfy the frequency condition that is met by the word 2, that is introduced by the word 2, and because of that this string cannot be created to word 2, which makes sense. You can also try this creating to word 2, and there is no way that you can create the word 2, right? So third is frequency of both strings, right? For every, sorry, frequency of both strings for arbitrary characters must be same, which means that if we have this as an array and this is 2 2 1, and so this is word 1 frequency, and word 2 frequency is also an array 2 2 1, sorry, 1 2 2, right? This is fine, this will work, because if we want to create this 2, right, so we want this 1, so we want this 2 to be created to 1, so we can swap this with this value, and this will be 1, this will be 2, right? Which basically means that if we can sort them up 1 2 2 and this is 1 2 2, we can find our answer, and by checking each and every character, each and every frequency, let's say frequency instance. So the first thing is, if word 1 dot size is not equal to word 2 dot size, then it's a violating condition. And if this is the case, then simply return false, because there is no way of converting word 1 to word 2. And then we will have the size as word 1 dot size. And the other thing is vector of int frequency 1 size 26, because there is only lowercase English letters. And then we have frequency 2, that is 26 again, size 26 again. And now you have unordered set. So we are using unordered set of characters in order to check the consistency of the characters in both of the strings. So it will be set 1, and then we have set 2. Now let's iterate over each elements of the word 1 and word 2 simultaneously and store their frequency and the characters in a set. So we have frequency 1 of word 1 I minus of a character in order to get the correct ASCII code, and this is plus plus. Then we have frequency 2 of word 2 of I minus of a character. This is also incremented, because initially the vectors have if we are initializing a vector with size, then all the values by default are 0. So now they will be equal to 1. And in this case, s1 dot insert word 1 of I. Similarly, word 2 for s2. Now, if s1 is not equal to s2, in that case return false, right? The consistency is not matching. Other than that, use a loop 26 and I plus plus, and if the frequency of I is not equal to frequency of 2 of I, then return false. But before that, we need to sort them up, because we are not checking the ith value character, we are checking the frequency only. We are not interested in if it's a frequency of A or it's a B or a C. We are only checking the number. So 2, 2, 1, and we have 3, 1, 1, or let's say we have 2, 1, 2, and we have 1, 2, 2. We are only interested in numbers, right? So that is why we are sorting them up. Sort frequency 1 dot begin, frequency 2 dot end, or frequency 1 dot end, and this should be 2, and this is 2 again. Now if every condition is checked and none of them was returning false, then we can say that if none of the violated conditions were true, then it means the string can be converted and this is a good string or a closed string. Okay, let's check once again. Yeah. Okay. So yeah, so this was the question. And if we talk about the time complexity, so for this part, yeah. So first, the time function will look something like this. The linear, because we are traversing on the element, and then we are checking the set. It will again be linear, and then we are sorting the elements. Now this sort value, so the frequency size is 26 and frequency 2 size is 26, which means that this is a constant operation, right? Because we are doing 26 log of 26, which is nothing but a very, not a huge value. So that's like a constant operation. And because that value will be something like 27 point something or 26 point something, I think 27 point something, so it's not a very big value, so that's why it is considered as constant. And then we are iterating over the 26 elements only, which is why it's also a constant. So this time complexity of the whole case will become linear, right? Which is why this is of linear time complexity. Now space complexity, we are using set, we are using vectors, which is a linear data structure, and we are only storing. So the set can have n number of elements, right? If every element is distinct, then it only will have 26 elements at most, and frequency will have 26 elements. And yeah, so the auxiliary space, so this is time, and the auxiliary space complexity will be constant again. Yeah, so this is it. Thanks for watching. Have a good day.